The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. This is Victoria Beal at the Ohio LTAP Center, and we're very pleased this afternoon to have a webinar for you on Rural Road Safety Attitude, Get One. And the reason we say get one is that we know and the information that Ray is going to talk to you about, that rural roads are an area that are definitely a focus for improving safety because they're some of the areas where we see the highest run off the road, crashes occur, and there are proven safety countermeasures that have been shared with us by the Federal Highway Administration that you can definitely deploy in your projects and use on your roadways to drive those crashes down in number and hopefully get to zero, which is what our ultimate goal is. We are using the new GoToWebinar software with this webinar, so I'm going to just talk you through a couple of housekeeping items here. You should have a panel that is on the right hand side of your screen, or maybe you've already moved it around, but in the control panel you're going to see a chat box. Feel free to put questions in there and I'll make sure that they're read to our presenter during the webinar. Also at the end of this webinar, GoToWebinar has the functionality to track attendance for purpose of issuing a certificate, so we'll work on getting those out to everyone. And we will also hopefully have a recording at the end, and we'll post that on our webinars page. But if something goes south and the recording doesn't work, at least you're here and you're able to participate in person, at least through a virtual connection. So with that, I'm going to go ahead and turn things over to Ray. I know he's got an action-packed hour for you. Ray, are you there?
I'm here. Can you hear me?
I sure can.
Can you hear me now?
Yes. There you go, Ray. All yours.
All right. Thank you, Victoria. And hello, everyone. Thanks for joining us today. I'm Ray Brushart from the Ohio LTAP Center, and today we'll be focusing on our rural road safety. And we'll be looking at some updated proven safety countermeasures from the Proven Safety Countermeasures Initiative that help us make our rural roads safer. And maybe you're thinking, one of the most popular questions we get is, where do I even begin to make my roads safer? And of course, that's the core question repeatedly posed to all of us that are working to make our rural roads safer, or all of our roads safer, and to save lives. And answering it isn't always quick and easy and can be a heavy lift, as you all know. But the way we do it is first we collect some data, and then we analyze the data, and we consider different improvements to research and develop implementation scenarios to work through. In the meantime, we need to get something safer out on the road. So it's good to have options available that are already vetted in advance, something to move ahead with quickly, but with confidence. And that's where these proven safety countermeasures come in. And so I want to show you some of these from the Federal Highway Administration's safety page. So got some pep talk slides there. The time is now versus later. But here's the heading from the FHWA Office of Safety, Proven Safety Countermeasures. You can just Google that and go to their website and see a lot of this. But the Federal Highway Administration Office of Safety began in 2008 to promote certain infrastructure-oriented safety treatments and strategies to reduce serious injuries and fatalities on our highways, and that became known as the Proven Safety Countermeasures Initiative. And then they went on to update that list in 2012 and again in 2017. So now that list of proven safety countermeasures has reached a total of 20 treatments and strategies that practitioners can implement to successfully address roadway departure, intersection, and pedestrian and bicycle crashes. And so transportation agencies are strongly encouraged to consider these research-proven safety countermeasures. So here's our list of 20 countermeasures from their website. Not all of them necessarily deal with rural roads, so we're going to whittle this down today to talk about, I think, 6 or 7 of these. First, a little background on roadway departure safety. Those are the type of crashes that we're really trying to focus in on our 2-lane rural roads to help decrease this type of crash, the roadway departure crash. So some of these countermeasures are designed to keep vehicles on the roadway, like our signage and pavement markings, friction, things like that. And then some of the countermeasures are designed to provide for a safe recovery if the car does go off the side of the road, and so they can come back onto the roadway quickly and safely. And then the third type of countermeasure is where there's going to be a crash. They've left the side of the roadway and they're going to crash into something. So we want to do our best to reduce the severity of that crash with our different hardwares and other strategies. So which of those 20 proven countermeasures are applicable to 2-lane rural roads? Well, today we're going to look at 7 of these. And so first will be our enhanced delineation and friction at horizontal curves. And then next was the systemic application of multiple low-cost countermeasures at stop-controlled intersections. And then we'll get into the rumbles, longitudinal rumble strips and stripes on 2-lane roads. And then we'll talk about the safety edge, and then the roadside design improvement at curves. And then we'll get into the local road safety plan, which is the new one, and road safety audits. So a little bit more about roadway departure crashes. First, let's define what a roadway departure crash is. It is a non-intersection crash in which a vehicle crosses an edge line, a center line, or otherwise leaves the traveled way. So you see some statistics there in that chart. First of all, roadway departure crashes make up 52% of all our fatal crashes. And then it breaks it down further into run off the road right and run off the road left and crossovers and other types of non-roadway departure crashes. So these countermeasures we're talking about today are part of our strategy called the systemic approach to safety. And a little bit about that, it's the reverse of the traditional approach that involved, you have to focus on the hot spots and do some safety studies and usually put together a higher priced roadway project, safety project, like straightening out curves or adding lanes to traffic or something like that. So the systemic approach involves low-cost countermeasures, and we place them where we find overrepresentation. And we install these countermeasures systematically at numerous locations, not limited to the hot spots on your crash map. So overrepresentation, if these crashes says 5% of the mileage equals 20% of the statewide problem, and we're focusing on a statewide reduction of roadway departure fatalities. To give you an even better idea what we're talking about with systemic, let's take a look at this exercise from our roadway departure class here at LTAP. There was if we go over to California, look at the rural areas of Humboldt County, and we look at the crash maps in those rural areas from 2005 through 2008, we'll ask you, do you see a particular place that needs to be treated? So 2005, if you look there, there's several red dots on the south end of their county and one up on the north end. And then we take a look at the 2006 crash map of the fatal crashes. You'll see there's some red dots more on their western edge and a couple on the eastern edge. In 2007, we see some more on the south side and one on the far northeast. None of these crashes occurred in the same curve. And same way with 2008, they had several more fatal crashes on the south side of the county and east side of the county, but none in the same curve from previous years. And so, it's a different location for each one of these fatal crashes over the 4-year period. But then we take a look at the fatal crash types instead of the locations. We focus on the crash type from 2005, 2006, 2007, 2008, and you'll see that the top 3 types of collisions each year are head-on, side swipe, and rear end. And if you look at the percentage of the crashes involving those top 3 across each year, you'll see that even the percentages are very similar. And so the conclusion would be that fatal crash locations are random in that scenario. However, the fatal crash types are predictable. And so here's a couple examples of township. In Ohio, we're kind of famous for our rural township curvy roads. They look very much like that Humboldt County location, don't they? So here's Meade Township in Belmont County. You see lots of different dots and different curves. And here we have Ross County, Ohio, Huntington Township. All these crashes are happening in different locations, different curves, for instance. So, we want to apply our low-cost treatments and systemically, and where we have these similar types of locations. So let's take a look at these different countermeasures. We'll start off with the first one on the list, and that was enhanced delineation and friction for horizontal curves. Again, we're focusing on curves here. There's so many of our rural road crashes, 2-lane roads happen in curves. A majority happen in curves. And so if we can improve the safety on the curves, and we're getting a lot of bang for our buck, big time. So, if we take a look at the data, 42% of curve crashes account for 42% of rural roadway departure fatalities. So definitely some room for improvement there. So let's take a look at our enhanced delineation treatment. So they help to alert drivers in advance of the curve and vary by the severity of the curvature and operating speed. And price ranges for these strategies are low to moderate. Let's take a look at some of these. The picture there is an example of chevron signs installed along a curve. So crash types addressed by delineation are curve crashes, head-on collisions. A lot of head-on collisions happen within curves, or people go out of their lane and cross the center line. Nighttime crashes, because with the latest delineation, latest signage and things they've improved retro reflectivity for nighttime driving, and other run-off-the-road crashes. There's also pavement marking. The OMUTCD and the national MUTCD, they have requirements for the use of edge lines, and we can even improve on them. The standard edge line is 4 inches. One of the improvements here you can make is make those white edge lines 6 inches wide throughout your curve to give better guidance throughout the curve as someone traverses through the curve. Also, yellow center lines, there's requirements for those on a lot of roads that have 6,000 vehicles a day or greater. That turns out, it's not a law against putting a yellow center line on roads that have less than that. You can also, under guidance, it says 3,000 and over. And then, of course, some roadways have been studied with even less cars than that for the center line treatment, and they reduce crashes as well. Other types of pavement markings are in-lane pavement markings. There's an example of just the curve is written on the pavement and the speed limit as well. Here's a PennDOT example of a advanced curve warning for the in-lane pavement marking. Some other stuff, we've even tried these in Ohio called the optical speed bars. If you see these, they the theory is that they give drivers the illusion that they're traveling faster than they are, so they slow down. And then also, if you have a guardrail on your curve, it's always good to have a reflective barrier delineation. And so, you should make sure that, as you see in these pictures, that you have retroreflective sheeting on the guardrail itself to provide guidance through the curve. Signs, and then we move on to our signs. And so crash types addressed by signing include curve crashes and nighttime crashes, mostly run off the road nighttime crashes. There's some examples of our advanced warning signs at the bottom of the screen there. And also on the screen is a picture of the NCHRP Report 500, Volume 7. There's several volumes to that report, but Volume 7 focuses in on a guide for reducing collisions on horizontal curves. So some statistics about the benefits of providing advanced warning signings for curbs. So, the Crash Modification Factors Clearinghouse, through their studies, show that just putting a sign up in advance of your curve, like the one you see in the picture, can reduce your crashes by 30%. So that's an amazing bang for your buck, isn't it, for just the cost of a sign? The more information you provide to the motorist in advance of the curve, the safer they will be. And then there's also guidance here in the National Manual, but also the Ohio Manual of Uniform Traffic Control Devices about what is required for signage and delineation in your curves. This lets you know when a advanced warning sign is required, when an advisory speed plaque is required or recommended, and chevrons as well. Here's some more pictures of advanced warning signs. And, I can't say enough about also adding the advisory speed plaque that lets people know the speed to slow down to safely drive through that curve. The picture in the middle also shows the placement of the signs and the chevrons. And again, here's a chart that helps with the requirements of your horizontal alignment sign selection, what's required and what's recommended when it comes to the difference between the speed limit and the advisory speed. And here's some more information on chevrons. Studies show that the crash reduction anywhere from 4 to 25% just for putting chevrons in your curve. And as you can see, as you go down there, the bottom one is head-on crashes, nighttime crashes, run off the road, and side swipe crashes. They had a reduction in crashes of 78%. So in places where they did not have chevrons. Another thing that really improves the guidance throughout the curve is to add the post-mounted sheeting or post-mounted delineation to the chevrons or the large arrow or to your advanced warning signs. It really makes those signs stand out. You can't miss them. And so there's also a chart in the MUTCD and Ohio manual as well as far as helping you determine the proper spacing of your chevron alignment signs throughout the curve. Here's some examples of some hardware that you use to install the chevrons so that they're adjustable so they would reflect the headlights. You can adjust them so that they reflect the headlights very well from coming from both sides of the curve. Some other examples are multiple curve signs. If you've got curves that are located within 600 feet of each other, you should have the multiple curve signs. And then here's some pictures of some bad signs. There's bad signs out there. So the retroreflectivity is not good, worn out, they need replaced. So it's important that all agencies have a very good sign maintenance program. And also take regular care of making sure your signs are where they're supposed to be, as far as chevrons go. If they're not aligned properly for the headlights, as you can see in this picture, some of those chevrons don't show up at night. Also, vegetation management is very important throughout the spring and summer, making sure that the motorist can actually see those signs in advance. So it's important to have a good vegetation management program as well. Okay, let's move on to the next countermeasure, and that is increased pavement friction for your curves. So this involves a high friction surface treatment, or HFST, another one of our highly cost-effective countermeasures. So your high friction surface treatments compensate for the high friction demand at curves, where the available pavement friction is not adequate to support operating speeds due to one or more of the following situations: sharp curves or inadequate cross-slope design. And so there's some benefits and statistics involving the friction. Let's see, and also the signage. So safety benefits: chevron signs, 25% reduction in nighttime crashes, 16% in non-intersection fatal and injury crashes. The high friction surface treatments have a 52% reduction in wet road crashes and 24% reduction in curve crashes. I've seen much higher percentages for that as well. Here's how friction enhances your safety during wet conditions. Polished roadway surfaces, that's where, maybe the roadway has not been resurfaced in a number of years, and so the aggregate has become polished, and so you lose friction value. And even speeders, if they're exceeding the advisory speed significantly, then they run the risk of skidding off the roadway. So we need to provide skid-resistant pavement surfaces so that we can reduce the likelihood of a vehicle leaving its lane and either crossing the roadway center line or leaving the roadway at a horizontal curve. So they focused in on this on the NCHRP Report 500, Volume 7. Let's see here. The United States Code 402, it says every state shall have a program to improve highway safety, such that there are standards for pavement design and construction with specific provisions for high skid resistant qualities. And that each state shall have a program for resurfacing or other surface treatment with emphasis on correction of locations or sections of streets and highways with low skid resistance and high or potentially high accident rates susceptible to reduction by providing improved surfaces. So improving friction to keep vehicles on the roadway, those are different crash types that address by improving friction: wet weather, other skidding, of course, curve crashes that we're focusing on today. And there is a guidance material that provides more information on that through NCHRP. You can actually Google this document and download it for free. NCHRP web-only document 108, Guide for Pavement Friction. Some strategies for reducing crashes. Where can friction benefit safety? So all these locations: horizontal curves, the approach to intersections where people need friction to help them come to a stop, and different grades, downhill grades. So some other factors related to skid crashes: road geometry, vehicle speeds, driver actions, weather conditions, and traffic characteristics. We can really get into some the science of friction. Of course, involves the laws of physics are at play here, of course, as you drive through a curve. It says here, the margin of safety against skidding on curves is defined as the difference between the available tire pavement friction and the friction demand of the vehicle as it tracks the curve. So here's some, if you want to get down to some science here, we show a chart here from NCHRP 108 involving pavement tire friction versus vehicle speed, and you look at the vehicle demand, where you have pavement tire frictional capability intersecting with friction demand of the vehicle, and at that point where it intersects, that's the speed of impending skid. And so if we can improve on the friction, we can actually improve the vehicle itself, keep it on the roadway at that speed. Here's the an AASHTO horizontal curve design model. If you look at the equation in the top left, it says E plus F. And E is super elevation of that curve, like a NASCAR track, the super elevation through the curve. F is the side friction factor. So those two values on the left are your friends as you drive through a curve. They are the only two forces keeping you on the roadway as you drive through a curve. And the problem with our rural roads is that a lot of our rural roads have no super elevation. And so all you're left with is your side friction factor helping you. So it's very important for our two-lane rural roads to that don't have super elevation to make sure they have a good level of friction. And here's more on that. So there's sometimes it says the skidding type of crashes happen primarily on curves at night, on local or collective roadways, and during clear weather. So it's not even, even on dry pavement, these skidding crashes happen in these curves. Another vehicle we have that has problems with curves are big trucks. You've seen, heard about trucks rolling over at interchanges and in curves. And when they study these rollovers, they determine that before the truck rolled over, they actually went into a skid and then they rolled over. So if we can prevent them from skidding by improving friction, then we can prevent the rollover. So the way we do this is to provide a high friction surface treatment. And so what we're talking about is putting down a commercially available resin-based product on the pavement, and then putting the a high friction aggregate on top of that. So here we, bauxite you see in the middle there is a very high friction type of aggregate, and that is the best aggregate out there for these high friction surface treatments. And in the binder you apply at first. It's made up of some sort of epoxy resin. So here's some pictures of an HFST installation. You see the workers on the left spreading out the resin, and then the second picture is a machine that spreads the aggregate evenly. And then there's other ways to do that, even by shovel, by hand, or some other, the fourth one over there is some sort of a machine that distributes the aggregate. We even tried this in Ohio, in Hamilton County, Ohio. This county road here had a high number of curve crashes run off the road. And in the year after this HFST was installed, there were 0 curve crashes. So what a reduction that was. Also, when this first came out back in 2012, I believe, there's lots of studies in several states. PennDOT, for instance, they studied a curve here. As you can look on the far right, second to the far right column, all the crashes in this curve occurred involving southbound vehicles. And so they wanted to try the HFST treatment in the southbound lane. So here the crew came out there at 8:30 a.m. and began their project. Here they are installing it. and by 2:30 p.m. in the afternoon that day, it was ready for traffic. And the results on this show, before installation, let's see, friction result, those are friction values. Before installation, there was 21 crashes, and then after installation, they had, of course, the 75 represents the friction value. It's a very high friction value, and compared to the control lane. And as you can see, they had 0 crashes in the year following the installation. So it were 22 crashes to 0. So you get really big, really good results from that friction treatment. So we want to see that friction treatment more often here in Ohio on our 2-lane rural roads. Okay, let's move on to our next countermeasure, and that is a systemic application of multiple low-cost countermeasures at stop-controlled intersections. You've probably seen, this probably looks familiar, our LTAP sign grant. We've been pushing to have these sort of treatments when we buy our road signs for our townships. It involves more advanced warning, like doubling up on the advanced warning signs for the stop condition at the intersection, and also for the through approach, doubling up on the advanced warning signs for the intersection. So doubling up and using oversized advanced intersection warning signs, even adding street name sign plaques, basically providing more information to the motorists as they approach the intersection, and also enhancing pavement markings that delineate the through lane edge lines, and also a properly spaced stop bar at the intersection. And there's other countermeasures as well, flashing solar LED beacons on advanced intersection warning signs and stop signs, or a flashing overhead intersection beacon, reflective panels on signposts. Those are definitely very helpful, and I think they're like $4 a piece, but they sure do provide really good advanced warning. Dynamic warning signs, the flashing electric signs that have messages. Also transverse rumble strips across the stop approach lanes, and the extension of the through edge line using a short skip pattern. And there's more to the list: skid resistant surfaces, new upgraded lighting, some pavement marking treatment called lane narrowing, peripheral transverse pavement markings, and dynamic speed warning signs. So these are all part of this initiative. Even like you saw it from Pennsylvania, where they put slow on the pavement markings. Let's put that word on the pavement. Other high friction surface treatment. Of course, roundabouts would even fall into this category. Adding left turn lanes at an intersection definitely adds safety. Or making sure an intersection is a 90-degree angle instead of skewed. That makes it safer. Okay, next we have our next initiative involves the rumble strips and stripes. And so these are either milled into the pavement or raised, and they are intended to alert drivers through vibration and sound that their vehicles have left the travel lane. They can be installed on the shoulder, the edge line of the travel lane, or at or near center line of the undivided roadway. And so a rumble stripe is where we put the rumble strips right on the edge line. And this can result in an increased visibility of the pavement during pavement marking during wet and nighttime conditions, which is a very good benefit. And it goes on to show you some data of the safety benefits. There's a 44 to 64% reduction in head-on collisions or opposite direction crashes or side swipe fatal and injury crashes. The shoulder rumble strips go anywhere from 13 to 51% reduction of single vehicle run off the road fatal and injury crashes. So the other one on the right shows a a 45% reduction in crash frequency after installation of rumble strips on rural 2-lane roads. So we want to see more rumble strips and stripes in Ohio on our 2-lane rural roads. You can read further about it on the, there's a booklet called the Decision Support Guide for Installation of Shoulder and Centerline Rumble Strips on Non-Freeways. And there's also an NCHRP Synthesis 490 called The Practice of Rumble Strips and Rumble Stripes. So there's some more data here showing very high crash reduction involving the rumbles. So we definitely want to see more rumbles on our 2-lane roads. And you can even, if you think there's going to be a problem with the people on the road about noise, you know, we can vary the depth and width and length and spacing of our rumble strips, and they still will provide a significant reduction in crashes. Here's pictures of the rumble stripe during rain activity at night, and so they really light up, and so it's very important. Okay, what else do we got here? Different variations of the centerline rumble strips. They're on double yellow. They're actually milled into both sides of the double yellow line. And there's milled across the markings, across the joint, or on both sides of the joint. So there's different ways to do it depending on the road that you're on. And if you're thinking that the bicyclists will hate these, we actually have a way to make them bicycle friendly by providing a gap every, you know, whatever distance you select, 30 or 40 feet or more, so they can go in and out, because bicyclists actually prefer to be in the lane if, you know, cars are not coming, because there's less gravel and broken glass and stuff in the lane versus on the shoulder. Okay, and it of course also helps them to hear the traffic coming from behind them as well. Also motorcyclists, you might think motorcyclists won't like these, but there's a big study of 9,845 motorcycles, or wait a minute, those are crash reports. And but anyway, the conclusion was of the study that no indication that centerline rumble strips pose a hazard to cyclists. So that was good. Also, you can even put the rumbles in chip seal pavements. It's been done in many places. So we don't see any reason why not to provide rumble strips on our rural roads. So our next countermeasure is our safety edge. It's been around for quite a while, but it's still on the list because it does such a good job in reducing crashes. And so it says here that pavement edge drop-offs can contribute to crashes. So they account for 53% of fatal crashes, roadway departures do. So when a driver drifts off the roadway and tries to the right and tries to steer back onto the pavement, a vertical pavement edge can create a tire scrubbing condition that may result in oversteering. And so if drivers oversteer to return to the roadway, like overcompensate, without reducing the speed, and they are prone to lose control of that vehicle. And so, and the resulting crashes tend to be more severe than other crash types. So here's a picture of a typical pavement edge drop-off crash that involved overcorrection. And so the safety edge is a solution to this because it provides a 30-degree angle shape on the side of the pavement, and it makes it very easy for the car to get back onto the pavement and stay in their lane. So some calculated benefit cost ratio are very, very high, 500 to 1,400. But that's because there's hardly any cost to adding this to your repaving operation. So you definitely need to check out adding the safety edge to your next resurfacing project. Make it your policy to do so on your 2-lane rural roads. So we're doing that at ODOT as well. If you look at our spec book, our 2019 spec has been integrated into it, so you can check that out. And you can contact the Office of Pavement Engineering if you have any other questions about that. What else we have? The next countermeasures selected here is called Roadside Design Improvements at Curves. So this involves either providing guardrail or cable, even cable barrier, or also installing a clear zone. And that's because 27% of all fatal crashes occur at curves, and 80% of all fatal crashes at curves are roadway departure crashes. And so these roadway design improvements at curves is a strategy encompassing several treatments that target the high-risk roadside environment along the outside of a horizontal curve, and they prevent departure fatalities by giving vehicles the opportunity to recover safely and by reducing crash severity. And these could be implemented alone or a combination of others and are particularly recommended at horizontal curves, especially where data indicates a higher risk for roadway departure fatalities and where cost effectiveness can be maximized. So here's an example of providing for a safe recovery, installing a clear zone, and which is an unobstructed traversable area beyond the edge of the through traveled way for the recovery of errant vehicles. And that area is free of rigid fixed objects such as trees and utility cabinets or poles or even trees. Yeah, trees. Trees can kill a lot of people, so do utility poles. Another treatment is to flatten the slope of the side of the roadway, which reduces the steepness of the side slope to increase drivers' ability to keep the vehicle stable and regain control of the vehicle and avoid obstacles. Or we can shield obstacles, provide barrier for slopes, fixed objects, medium barrier, and there's also new types of guardrail and barrier that are been upgraded to make them safer. So, since not all roadside hazards can be removed at curves, installing roadside barriers to shield unmovable objects or embankments may be an appropriate treatment. So there's a treatment, of course, along with the signage, we have delineation and guardrail there. Cable barrier is one of the treatments at curves. It's a flexible barrier made from wire rope supported between frangible posts. And they may be the most versatile and forgiving barrier systems available for reducing the severity of run off the road crashes. So here's this is from the ODOT Roadside Safety Field Guide, Cable Barriers and Curves. They can be expected to have increased deflection, and so reducing the post spacing may be an effective countermeasure, but objective criteria have not yet been established. High tension cable systems should be considered for severe curvilinear alignments. Then we have our regular type of guardrail, a semi-rigid barrier, usually either steel box beam or W-beam. These deflect less than flexible barriers, so they can be located closer to objects where space is limited. And so another one from the ODOT there, they're also called semi-rigid systems. Some examples are the Midwest guardrail system or the strong steel or wood post W-beam with wood or plastic blockouts. We've also updated the terminals of our guardrails, so the tangent versus flared, and this is the energy absorbing versus non-energy absorbing. So here's some pictures of the energy absorbing and crash-worthy terminals. Here's a list of roadside design strategies from the Roadside Design Guide. The first we would like to remove the obstacle in that curve, or redesign the obstacle for safe traversal, or relocate the obstacle further from the road, or reduce the obstacle severity, make it breakaway, like signposts, or shield the obstacle, or at least delineate the obstacle if we can't do anything else. So here's this culvert end here has caused a lot of crashes, very bad crashes, but so the idea is to make that traversable. Same way with this one, you can see this picture shows the crosses in the background where a fatal crash happened, where there's a rollover because they hit that concrete culvert end there. So here's an example of a culvert that they made traversable. And so a 36-inch pipe requires the use of that pipe right over it. Here's another example of a treatment to make the culvert traversable. Breakaway sign support's another option. So the MUTCD requires crash-worthy sign supports on all public roads, or at least delineate it. So there's a utility pole that has some retro reflectivity on it so they can at least see it. Okay, our next initiative is to create a local road safety plan, or LSRP. And this plan provides a framework for identifying, analyzing, and prioritizing roadway safety improvements on local roads. And the LRSP development process and content are tailored to local issues and needs. And the process results in a prioritized list of issues, risks, actions, and improvements that can be used to reduce fatalities and serious injuries on the local road network. So why do we want you to develop the local road safety plan? Because while local roads are less traveled than state highways, they have a much higher rate of fatal and serious injury crashes. So developing an LRSP is an effective strategy to improve local road safety for all road users and support the goals of a state's overall strategic highway safety plan. And so some aspects common to local road safety plans include stakeholder engagement, representing the 4 E's. The 4 E's of roadway safety, which are engineering, enforcement, education, and emergency medical services. You have a collaboration among municipal and county or federal entities to leverage expertise and resources. You know, a lot of our roads go in and out of different jurisdictions, from a local government, a village or town or township, and into a county road jurisdiction. Identification of target crash types and crash risk with corresponding recommended proven safety countermeasures. So you'll be using these countermeasures that we've discussed today in your local road safety plan. You can also develop your own timeline and goals for implementation and evaluation. So you would use the LRSP as a tool for reducing roadway fatalities, injuries, and crashes. And the plan would be viewed as a living document that can be updated to reflect changing local needs and priority. So if you want to find more information on developing a local road safety plan, you can, there on the right, I have a reference manual from FHWA called Developing Safety Plans, a manual for local rural road users. You can just Google that document to find it.
Hey, Ray, I'm going to jump in here real quick too and remind everybody that I put a message in the chat pod letting them know that there are 2 handouts available, and this covers the funding portion of the webinar announcement we had sent out. And one of those handouts is actually has information on how to get assistance from ODOT if you are interested in establishing a local road safety plan. We actually have a program where you can apply and they'll assign a consultant to assist you with getting that set up. So if you're interested in that, the information is there on the 2 handouts that we've uploaded, along with information on different funding programs that are available for safety improvements. So thanks, Ray, for letting me interrupt.
No problem. So the local roads experience 3 times the fatality rate of the interstate highway system. So that's just another reason as to why we want locals to develop these local road safety plans. So there's some more information on how to develop your local road safety plan. You should first consider addressing the following questions. What is the purpose or goal, and which agencies are critical to include during your plan development? How will safety problems be identified? How will improvement strategies be identified, prioritized, implemented? And how will the plan be monitored and updated? And so it gives you a step-by-step guide by how to establish your working group and review crash your crash data and establish goals and countermeasures and implementation and assessment of the plan. And there's another resource for you there on the right from the Federal Highway Administration called the Strategic Highway Safety Plan, available on their website there, safety.fhwa.dot.gov/HSIP/SHSP. There you go. Next, our last countermeasure or initiative is called Road Safety Audits. These two have also been around for quite a while. Maybe some of you have even taken a road safety audit workshop here that we provide at least every other year at the Ohio LTAP Center. I know we're going to have one in 2020. But a roadway safety audit is a proactive, formal safety performance examination of an existing or future road or intersection by an independent and multidisciplinary team. And the safety benefit, anywhere from 10 to 60% reduction in total crashes. While most transportation agencies have established traditional safety review procedures, a road safety audit is unique because it's performed by a multidisciplinary team independent of the project, and it considers all road users, and it accounts for human factors and road users' capabilities, and it's documented in a formal report, and it requires a formal response from the road owner. Lots of benefits from a road safety audit. It reduces the number and severity of crashes due to a safer design and reduced costs resulting from early identification and mitigation of safety issues before projects are built, improved awareness of safe design practices, increased opportunities to integrate multimodal safety strategies, and proven safety countermeasures. So again, you're going to be looking to implement the countermeasures in this in the safety countermeasures initiative here, and expanded ability to consider human factors in all facets of design. Shows here the 8 steps of a road safety audit. The yellow diamonds are the design team and project owner and or roadway owner, and then the blue diamonds are the RSA team. So it starts off with the design team and project owner identifying the project and then selecting the members of the RSA team, and then the team would conduct a startup meeting and then perform field reviews and then conduct analysis and prepare a report, and then they would present the findings to the project owner, whether that be the county engineer or a township trustees or maybe even the state or a city engineer. And then the design or the project owner would then prepare a formal response to that report and then incorporate findings into the roadway. Here's some pictures of an RSA in progress of the field review with the multidisciplinary team. So that team might be made up of not just safety engineers or roadway engineers, but also maybe even residents on the road in question that are very familiar with it, and also law enforcement and all sorts of people of different backgrounds. So here's the differences between a road safety audit and a traditional safety review. So as you can see, the safety audit is performed by a team of that's independent of the project, multidisciplinary, considering all potential road users. They're accounting for road user capabilities and limitations. Also generating a formal RSA report, and that report is an essential element of an RSA. Traditionally, safety reviews involve a safety review team that's usually not completely independent of the design team, and performed by a team with only design and or safety expertise, and often concentrates on motorized traffic, or does not normally consider human factor issues. They don't generate a formal report or generate a formal response report. So those are some big differences. Some other road safety audit resources, like I said, LTAP, we're going to be offering a road safety audit workshop in 2020. So you can be looking out for when we notify you of that. And then some other RSA resources you can just Google and check out. You can download these or view them. The FHWA Road Safety Audit Guidelines, or a model RSA policy, RSA newsletter, and road safety audit case studies. There's also several more. It's a long list of road safety audit resources that are out there. So we've gone over this entire list of these proven countermeasures for two-lane rural roads, and I hope that you'll consider these countermeasures on your local roads to improve the safety on your roads. So I'm open for questions and discussion at this time.
And Ray, we haven't had any questions come in yet to the chat pod, so apparently you've been doing a great job of answering all of them as you went. But if anyone does have questions, we would be happy to entertain those questions either via the chat pod or just message me, and I'll unmute you and allow you to ask the question through the audio. Ton of great information.
All right, they can contact me directly, and I'll be happy to respond to them directly.
They sure can. All right, well, we'll send Ray's contact information out after the webinar concludes. We are only 4 minutes shy of 3 o'clock, so I say we go ahead and call things. And thank you, everyone, for participating today. We appreciate your time and your attention to the information on the webinar, and hopefully you'll be able to put it to great use driving down the crashes on our rural roads. Thank you. Thanks, Ray.
Thank you, everybody. Yep, you're welcome.